Welcome back, Caymans. Mr. Eicher coming at you once again with a lesson about probability and two-way tables. We're going to be looking at starting with part J in this video. We did all this stuff in the previous video. So let's look at J. What is the probability a student says about the same and they go to bed at 10:30 p.m. to 12 a.m.? So this is an and. We're picking one student, about the same, and 10:30 to 12. So about the same, 10:30 to 12. About the same, there's about the same, 10:30 to 12. It looks like there are 6 students who are both of those at the same time. So that answer would be 6 out of 50. 6 out of 50 who are both. Question K, what's the probability a student says more time and after 3 a.m.? More time, and after 3 a.m. there's 3 students out of 50. 3 out of 50. And then next we'll calculate the conditional probability. In the very first lesson, 2 videos ago, we were talking about conditional probabilities. And you know a conditional probability if you see this given, sometimes at the front of the sentence, sometimes it might be in the middle of the sentence, but it says given you select a less time student. So less time student. What's the probability they go to bedtime before midnight? Go to bed before midnight. So I really like conditional probabilities, especially with this Apple Pencil that I got. It's cool because we get to do a little shading. I love me some shading. So given you select a less time student, we're only looking at the less time students. We're only looking at these 18 students. So that means we can completely ignore, here comes the shading. Woo, you might not want to do this shading because it might be hard for you to read on your paper, but I really like shading mine. So we're only looking at the less time. Given you have a less time student, what's the probability to go to bed before midnight? So before midnight, here's midnight. Before midnight would be these people and these people. So there's 6 of them out of 18. This is the first one on this lesson. We saw this last lesson, but the first one on this lesson where we're not going to divide by 50. And that's a key point with conditional probabilities. We have 3 plus 3 out of our total, 3 plus 3 out of our new total, 18. So really, in doing that, we're we're having our denominator not as the total, but the total condition, the total less time students. And that's where that 18 came from. So that's a conditional probability. Those are really common on the SAT and the ACT, especially with two-way tables. So let's check out a couple more. The next 3 are all conditional probabilities. So I'd encourage you to pause the video and see if you can come up with the answers. And you can leave your answers as unsimplified fractions. So first on M, given you select a more time student, what's the probability they go to bed? What's the probability they go to bed after midnight? So we're looking for the more time students after midnight. So let's see, more time student, get rid of some of this. More time student. So more time students, we're only looking at these students, so we get to do the shading, get rid of all the ignoring all of this. Now, I mean, as long as you can ignore it, you don't have to shade everything out. But so given that we're looking only at the more time students, what's the probability they go to bed after midnight? So after midnight, there's midnight right there. After midnight would be all those. So we're looking at 3 plus 4 plus 3 out of 13. So what is that, 10? 10 out of 13. 10 out of 13. And then the next one, given that you select a before midnight student. Now this is going to be a little different shading. Given that you select a before midnight student. Before midnight student. So before midnight, here's midnight. Before midnight would be all the students above this green line. So we're ignoring now all these students. So all these students are the before midnight students. So the question is, given that you select a before midnight student, what's the probability they spend less time in distance learning? So less time, that would be these people are spending less time on distance learning, 6 of them, out of the total. And the total isn't 12, but the total is this combined total, since we have a couple of the options here, since we're doing before midnight. So that looks like it's 6 out of 15. So hopefully you got that when you tried it on your own, 6 out of 15. And then lastly, given you select an after midnight student, so after midnight, okay, let me do my erasing here. After midnight, given that you select as, so here's midnight, so we're ignoring all these students. Given that you select an after midnight, what's the probability they spend less time? So less time would be all these people. Be careful not to, maybe I should shade, these totals aren't correct totals anymore because we've gotten rid of, like we've thrown out these people and these people, which were contributing to those totals. Okay, so we want the less time given they go to bed after midnight. So that looks like it's 12 total students there, if I'm adding those right. And then the total we have are out of these totals, which looks like 35 if I added those right. So it looks like our answer is 12 out of 35. 12 out of 35. So the 35 was the after midnight students. And the 12 was the after midnight and less time, is how we got that. Okay, let's do just 2 more, and then we'll end this video and pick it up on another video. So 2 more questions, kind of different, but 2 more questions. We're going to go up here. Let me clean this up a little bit. Nice and effective. All right. So, just 1 more question. Let's say now we select 2 students, not just 1, 2 students from this sample. What's the probability that both students are spending about the same amount of time without replacement? Now this without replacement, we talked about in a previous video, that means once a student is selected, we don't put them back. Put them back. They can't get reselected. This is without replacing them. So that means our first student we're going to select. I kind of like to do this. This is 2 fractions. Since we have 2 students, we're going to have 2 fractions that we multiply. These are being multiplied. So the first fraction, this is the first, is spending the same amount of time. And then this is the second, is spending the same amount of time. So there's 2 sets of fractions for 2 students. So let's see, what's the probability that the first is going to be spending the same amount of time? So about the same amount of time. There are 19 students out of 50. This is not a conditional probability, so we use that 50 again. So 19 out of 50. 19 out of 50. Now, what's the next fraction going to be? Well, if we're not replacing the first student, that first student's represented right here. Here's the probability of picking that first student. Now they're gone. They've been chosen. How many students do we have left to pick from? Well, there are 49 students left to pick from. And how many of those 49 would spend the same amount of time? Well, it's not 19 anymore, right? Because we just picked one of those 19. So really we have 18 students left over. So this one we really should multiply. We have 19 out of 50 times 18 out of 49. And the answer that I get rounded to 3 decimal places is 0.1396. So rounded to 3 decimal places would be 140. So that's our probability. This is our probability, which is a number between 0 and 1. Now, if you wrote it as 14%, that's still acceptable, but since it's a probability, I like to write the number between 0 and 1. So that's an example of without replacement. Now, if we had been asked with replacement, then the second fraction would be exactly the same as it was originally. It'd be 19 out of 50 again if it was with replacement, because the same person could be selected again. But I think that's good for this video. Thanks for watching. Give me a thumbs up if you liked the video, and please message your teachers if you have any questions. We're here to help. And thank you for all your hard work with doing math distance learning virtually.